Hi everyone, welcome back to Chemistry Portal. I am Sudhanshu Kumar and today we are going to talk about magnetic quantum number. Right? As we have already discussed the principal quantum number, Azimuthal quantum number, and today's we will talk about magnetic quantum number. Right? So first of all, the symbol, it is denoted by ML, right? So first of all, write here a small m and then write here a small l in this subscript. Okay, so this is the symbol of magnetic quantum number. So now the second point, magnetic quantum number. It determine the spatial orientation of the orbital, right? It means how the orbital is oriented in the 3D a space, and that things who will tell magnetic quantum number, right? So second point, very important, magnetic quantum number, it determine the spatial orientation of the orbital, right? Now what is the value of magnetic quantum number? So magnetic quantum number has integral value between minus L to plus L. Okay, minus L to plus L. Only we will take only integer value between this number, right? Minus L to plus L. For suppose, this chart is very important. You have to remember by heart. Okay. Suppose if you have L equal to 0, 0 means it is S orbital, and if you have L equal to 1, it means it's a P orbital. If L equal to 2, it means it's a D orbital. If L equal to 3, it means it is a F orbital, right or not? Okay. Now let's take some example here. Suppose if I give you P orbital, and now if I ask you what is the possible magnetic quantum number, so first of all, for P orbital we know that L equal to 1, right or not? So right here L equal to 1, and then the possible ML value between is what? Minus L to plus L, right or not? And because for the P orbital we have L value 1, so it means the possible value is what? Minus 1 to plus 1, right? Minus L to plus L. Okay, and between this minus 1 and plus 1 we have three integer value, that is a minus 1 itself and 0 and plus 1. Okay, so these three different spatial orientation possible for the P orbital. Okay, minus 1, 0, plus 1, these number, how many number we got? Minus 1, 0, plus 1 means we have three different spatial orientation of this P orbital. Understood? And this minus 1 we generally write Px, and 0 it is Pz, and plus 1 it is a Py. Okay, and now it's a very important note here. This ML value, these are what? Minus 1, 0, plus 1, these are the ML value, right or not? These are the ML value. And how many we got? How many ML value we got here? 3 value we got, right or not? It means three different spatial orientation possible for the P orbital. Okay, one is a Px, one is a Pz, one is a Py. Okay, it means the shape of the P orbital is oriented in all the three direction, right? Px, Py, Pz, like this. Okay, we will talk in more detail. Okay, now note ML value plus minus 1 associated with Px and Py. Okay, so what does this mean? This minus 1 can be Py also. This minus 1 can be Px also. Okay, we can use vice versa. Understood? ML value plus minus associated with Px and Py. Okay, we can take plus 1 as a Px also, we can take minus 1 as a Px also, we can take plus 1 as a Py also, we can take minus 1 as a Py also. No problem. Understood? Right? But, and this value, this ML value plus minus 1, it represents the 2p orbital in the xy plane. Okay? Understood? Because this plus 1 and minus 1, see here, it is a Px and Py. It means what? It means this 2 value represents the 2p orbital in the xy plane. Clear or not? Okay. Now, but 0, the ml value 0, this is for pz as per convention. Okay, and how the convention came? Convention came due to projection of orbital angular momentum along the z axis taken by convention. Understood? So please remember, ml value 0, it is for pz. Understood? For pz. For pz, ml value is 0. It is fixed. We can say that. Okay, understood now? And how this 0 came? And why the 0 is fixed for pz? Because after this lecture, we will study orbital angular momentum. In the next video, we will talk in more detail. Okay, so this ml value correspond to 0 for pz, right? And due to projection of orbital angular momentum along the z-axis, that's why we take ml value 0 for pz. Okay, for now you can just remember plus minus 1 we can use for px also or py also, but ml value 0 we use for pz as per convention. Okay, now see, we have these are the p orbital shape. The shapes are not changing, right? See, all are dumbbell shape. All the p orbitals has dumbbell shape, right or not? If the lobe, if the lobes on the x-axis, it is called px. If the lobe oriented on the y-axis, it is called py. If the lobe oriented on the z-axis, it is called pz. Understood, no? So, means what? Magnetic quantum number tells us the orientation, means how the lobes are oriented in the space. This lobe is oriented in the ph direction, it is called px. This lobe is lying on the y-axis, it is called py. This lobe is lying on the z-axis, it is called pz. So see, all the p orbitals having a same shape, right or not? All are having a dumbbell shape, but different orientation. Means what? They have, the lobes are in the different direction, the lobes are in the different orientation in the 3D space. One in the py, one in the x-axis, one in the z-axis. Understood? So p has three types of orbital. One is a px, one is a py, and one is a pz. Okay? Clear, everyone? I hope this is clear for everyone, right? If you have any doubt, you can comment in the comment section. Okay, I will try to reply. Okay, now let's suppose for d orbital we know that L value equal to 2, right or not? See here, for d orbital L value is 2, right? So now the possible ml value is what? Now find the ml value for d orbital. How we can find? We have the formula, right or not? Magnetic quantum number has integral value between minus L to plus L, right? And we know that for d orbital the L value is 2. It means what? Minus 2 to plus 2, right? See here. So ml value between minus 2 to plus 2. How many values are possible here? Minus 2, minus 1, 0, plus 1, plus 2. How many value we got? 5 value we got. 1, 2, 3, 4, 5. So it means what? 5 different spatial orientation of d orbital. This is the meaning of, that's the meaning of magnetic quantum number. Okay, it tells us different orientation. How many types of orientation possible in the d orbital or in the p orbital, like that. Okay, so in the d orbital, the 5 different types of spatial orientation is possible, and this minus 2, it is called dxy, minus 1 dxz, 0 dz square, plus 1 dyz, plus 2 dx square y square. Now see, this 0, this ml value 0, it is, this 0 value corresponds to dz square always. Okay, dz square means ml value is 0. Okay, fixed by convention. Okay, understood? But minus 2, minus 1, plus 2, these we can interchange. We can take any one. Dxy can be minus 2 also, can be -1 also, can be +1 also, can be +2 also, okay, no restriction. But for dz square we take ml value 0, and rest of all it can interchange, okay, now understood, right? Okay, now so what does this mean? dxy, dxz, dyz, dx square, y square. It tells us the orientation of lobe in different axis, okay. Suppose here dxy. dxy means what? If the d orbital lobe is present between the x and y axis, this is your x axis, this is your y axis. If the d orbital lobe are present between the x and y axis, it is called dxy. If the d orbital lobes are present between the y and z axis, it is called dyz. If the d orbital lobes are present lie between the x and z axis, it is called dxz. Okay. Now if the d orbital lobe lie along the axis, on the y and x axis, it is called dx square, y square. You can see here, you can observe here, dxy, dyz, dxz. The lobes are between the axis. But in the case of dx square, y square, the lobes on the axis, on the x and y axis. Understood? Now, for this one, for dz square, the lobes on the the lobes on the z axis. And around the z axis, you have one ring. Understood? You have one ring here, okay? And the lobes on the z axis. This is called dz square. So overall, we can say that magnetic quantum number, it is denoted by ml value, right? And it determines the spatial orientation of the orbital, and magnetic quantum number has integral value between -L to +L. Okay, understood? And we have some notes. Total value of m, or total value of orientation, or total number of orbitals in a subcell is equal to 12 plus 1. Very, very important. For suppose, if I want to find for p orbital, how many orbitals present in the p subcell? We know that for the p subcell, L value is 0. Sorry. For the p subcell, we have L value equal to 1. So now put the value here. 2 into 1 plus 1. How much we got? 3. It means what? The p subcell has 3 types of atomic orbital. One is a px, one is a py, one is a pz. Understood? So this is a note. Total value of m, or total number of orientation, or total number of orbitals in a subcell equal to 2l plus 1. Be careful, okay, be careful. ml does not tell the shape. ml value, it determines the spatial orientation. Very, very important. Shape, who will tell? Shape, for the shape, L value is responsible, okay. Azimuthal quantum number tells us the shape. Understood? But ml value is responsible for the orientation. Now note, dxy, dyz, dxz orbitals are non-axial d orbital, but dx square, y square and dz square are axial d orbital. Why axial? See, because all the lobes are on the axis, it is called axial orbital. Here also lobes on the axis, it is called axial orbital. But here lobes are between the axis, it is called non-axial d orbital. All these three are non-axial d orbital. Okay, that's why dxy, dyz, dxz orbitals are non-axial d orbitals. Okay, so this is all about magnetic quantum number. I hope you understood, and if you found this video helpful, so please like, share and subscribe our channel Chemistry Portal, and all the links are given in the description box. You can go through it, and you can join our Telegram channel, you can join our WhatsApp group, you can follow us on the Instagram and Facebook and so on. Okay, thank you everyone, thanks again.